Hi guys, this is episode 5. This is actually further to episodes 3 and 4, where we actually proved that we could access the trackball and the keyboard. So the thought was, now what can you do with that? And one thing that came to mind is creating a remote for either a PC or maybe a Android TV or something like that through Bluetooth. So the idea is, you might have seen devices like this. This is a so-called air mouse. This here you can use in order to control the mouse, and it's got some buttons there, but on the back there it's got a little keyboard that you can actually use in order to, how when you have those streaming devices, quite often you got to put passwords in, and I got this awkward little keyboard on the screen that you have to move the cursor up and down and click on them, and it's a pain in the neck. So that's where these guys come in. And there are others that are more extravagant. You can actually use those like on mini PCs and so on. This is one here, got a little trackball on it, and buttons to click, the left and the right mouse button, and again with characters on there and so on. So I thought it would be neat if we could emulate that with our LILYGO T-Keyboard. So let's have a look at what we can do with that. So the first thing we need is a suitable library to control the Bluetooth HID devices, human interface devices. That is very complex to do if you had to do that all by yourself. There's a great deal of code behind these things. So I found several over there, did a Google search on BLE combo, and this is one that I found, and that's the one that I have implemented. It seems to work okay. There are others that have different syntax and so on, and some different features. So depending on what you're trying to build, you may or may not use this one. You could use one of the other ones that we have. For instance, there is one over here. And in any case, this is the one that I use right now. And so what you do is you actually get the code, download the zip file, which of course I have already done, and you would unzip it in the lib folder of the project that you would develop under Platform IO or PIO Arduino. And this is what I've done, and I'm called ESP32 BLE combo, and this is simply all the files that came from the GitHub site with relatively minor changes, which we'll go to. So, okay, so this is the code that we have. Now, as I put in the comment there, it can be used as starter code if you were going to make a more advanced project where wants to make one of these remotes. And you should look at it as test code. At this level here, you'd have to edit it and add some features to it and stuff like that. But nevertheless, it will get you started quite nicely. So, because we have that ESP32 BLE combo library that we dumped into this lib folder here, we can now refer to it like so. We can say include BLE combo. That's all we need to do. And inside there, it actually has a keyboard and a mouse. Now, because of that, I previously created a keyboard HPP file for the actual feedback keyboard, but that of course clashed. So I renamed that to T-Keyboard, and in actual fact, the class 2, I changed the name to T-Keyboard so that there would be no confusion in the code. And there's just a few sort of functions here to support stuff. Show a message on the screen in the middle on the LED screen that it has, TFT screen. I have a little function here to test the battery level. And when you go to the Bluetooth devices, I have already paired the thing, of course. You'll see T-Deck keyboard mouse paired, and the battery level is at 51%. So that is actually working. But it's not connected right now, it's turned off. So let's have a look at that later on. So that's what this does. You can override the level and set it to a particular level. That's basically, that was for testing. But it does an analog read on the battery ADC pin that the T-Deck has. And with a little bit of experimentation, I found that if I divide it by 742, it comes back with a reasonable approximation of the actual voltage of the battery. It seems to be coming back with 4.1 when I plug it in to the USB port. So I therefore use that 4.1 here as a value to use. So 100 divided by 4.1 times the battery voltage. So if it is 4.1, it comes back with 100%. If it comes back with less, it'll be a lesser percentage. I don't know if that's correct or not. It's basically for testing. You would have to, there must be, most likely there is a better formula for that, but you'd have to experiment with it and see. I don't think it's that important anyway. Okay, then we end up setting the battery level. If the battery level, current level, is the same, then it doesn't do it, otherwise it sets it. It's really test code. Okay, setup, all that's the same as before. We talk about that in the previous episodes. I encourage you to look at those. So we've got the keyboard and the trackball setting up. But now we've got keyboard, which is the BLE combo keyboard, begin, and a mouse begin. And we delay for half a second just to give them some time to get established. And the keyboard, to make sure that this is when the keyboard is connected, that's actually to do with the Bluetooth connection. So we need to give it some time in order to get connected to the Bluetooth, and I'll give it up to a minute there. And if it can't connect within a minute, it says keyboard is not connected. But if the keyboard is connected, then it says keyboard and mouse ready, and it sets the battery level. If there was any movement on the trackball, then we actually use this function here, this mouse move, and that movement thing is actually, that's the volatile movement, a variable that actually is controlled by interrupt-driven routines. So, because remember, the mouse is not connected to a coprocessor, it's connected directly to the main processor, and we don't want to continuously scan for changes up, down, left, and right. That would be too time consuming in our main loop, so we do that in the background via a interrupt, and that is all fully explained in the trackball episode, so I encourage you to look there if you're more interested in that. There's a couple of keys on that keyboard. This comes back with some odd codes, so we can actually use that to do some different things. So just for testing over here, there's a little key that has a speaker on it that obviously you could use for, turning a mute or speaker on and off or something like that, but we don't have a tab key, so I picked up the code there, that's code 4, and I instead changes it to code 9, which is a tab key, and the enter key on there actually comes back with a carriage return, but Microsoft Windows at least wants to see a line feed character for that, so we changed it from 13 to 10. And there's another key there that has a little microphone on it, and I guess you could use that to turn the microphone on and off, but we changed that to the delete function, just to show that you can do that. In a real application, you might actually use it for using controlling the microphone or something like that. All right, so that's that. And in the loop here, it actually gets a key value from the keyboard. If there is a key value, it'll be not anything but 0. Then it actually processes it, puts a little message on the screen like the keyboard code did in the other episode. This is so that we can actually see what the key code was, and the key value displays it. But then it actually does a keyboard print, and this actually is outputting it through the Bluetooth HID connection that it has, in this case, to the computer. If the trackball is available, then we check if the checkball button was actually clicked. If it is, then we send a left mouse click, and we give it a little delay over here because it's hard to click that trackball without moving it, and we don't want the movement to be recorded while you're clicking it. So we actually delay for 1/3 of a second so that it can settle down, and then if there was any movement, we just reset it and delete it. Otherwise, if the trackball wasn't clicked and it was just movement, if there was any movement, then it says display moving mouse, and then it goes to that function to move the mouse, and then again we reset movement because it's been used. And then in the loop there, we set the battery level. I have a very small battery connected to this T-Keyboard, and you will actually be able to see that going down as it is running. Wouldn't last very long. In any case, yeah, so that's the move mouse that it was calling there in order to move it. So that is all that is. If you're wondering how hard it is to do that HID stuff, it is incredibly complex. So we can look at some of this code in here. We have BLE combo that does nothing more than exposing the mouse and the keyboard. And then we have the combo mouse. There's mouse things, there's a keyboard, there's keyboard related stuff, press buttons, write stuff, and all that kind of things. Then we have BLE connection status. And that's when you start to see code that is actually part of the standard library. It's starting to get into BLE server and BLE characteristic. And then you get all these other things: BLE advertising, BLE characteristic, BLE service, BLE security, BLE address, BLE UUID. So, and you can drill down on those things, but it goes further and further, and eventually end up with a HID.h for the actual HID devices and so on. But the way Bluetooth works is, if you've got a Bluetooth device, it advertises itself. And the Bluetooth radio, like in your PC or your device, picks that up and it says, oh, there's a Bluetooth device available. And then when you say, okay, look for devices, it'll pick that up and it'll display it to you. And then you get the opportunity to connect, pair it, and all that kind of stuff. But it has certain characteristics. I mean, you can have Bluetooth audio devices, you can have Bluetooth human interface devices, keyboards and mouse and game pads, and so on and so on. And there's security involved with it. And each one of the devices has an address and a UUID and so on. And it's very complex the way it works. So we are happy that somebody else did all the work on that, look up the specifications and write all that code. Oh, and the only other thing to mention here is that BLE Combo Keyboard 8 has the identifier in it for the device, and I put TDEC keyboard / mouse in there. Of course, you can put anything in there. Device manufacturer, I put my little, I put Tech Relief in there, and default battery level is 100. It's fine. So that's the only thing I edited. The rest I left alone, so that you can actually recognize it when you go to the Bluetooth settings. When you go to Bluetooth settings, I have already paired it. Obviously, you would normally hit add Bluetooth on another device and it would show up there. And then you click on it, say connect, and then it ends up like this. So the last time, it's not connected right now, it's actually turned off. So the last time I had it on, it was 51% battery power. And let's turn it on. Okay, I turned it on, it's connected, and 56% battery power, 55. As I said, it's a very, very small battery in there, and it will go down pretty quickly. So it's settled on 51% right now. And if I plug it into the USB port, you will see it'll go up to 95% and it'll be charging. All right, so notepad over here, and we will put the cursor in there. So I can use the trackball, and yes, indeed, as you can see, the cursor is moving. And if I type something, hit the enter key. Remember, we were translating that. Oh, that was the backspace, sorry. Hit the wrong button there. That was the enter key. And of course, remember, you have to hit that sim button each time. It's not like a shift key. Anyway, we've got backspace. Remember, we put tab on this speaker key, did we not? Yep, tab's working. And I move the cursor over here somewhere and click it. Yep, move the cursor in there. And if I hit this, and yep, the delete is working. Okay, so that's it. We have success here with this, and we can go and do something else next. Next is going to be the sound, speaker, microphones, and so on and so on. So you can actually use this code in order to as a starting point for making a remote keyboard and mouse device. and we will have a look what else we can do in the future. You could potentially also introduce the touchscreen as a trackpad. It would be possible as well, but in any case, this was an interesting little test. So don't forget to like, subscribe, and press the bell button and everything. Look in the description for the other videos so that you can catch up if you haven't seen those, to know how we got here. And then we move on to testing some more of the devices in that LILYGO TDEC. And right at the end, of course, we're going to put all of it to use in some application. Anyway, I will see you guys later. Bye bye.